Hello, good afternoon, good morning. Welcome to IA Bioenergy webinar series. My name is Chiara Benetti, and I welcome you on behalf of ETA Florence Renewable Energies, technical organizer of this webinar. Today's webinar is entitled Lowering Hinders for Maritime Biofuels, Identifying Means to Increase the Use of Biofuels in the Marine Sector. The webinar is moderated by Thomas Walsh, CEO of Renatech Bioresources, and the speakers of the webinar will be Thomas Ekbom, Task Leader of IA Bioenergy Task 39, David Bauner, CTO of Renatech Bioresources, Jürgen Jacobi, Senior Project Developer of PTX and European Energies Vertige, and Lasse Bangstein, Chief Communications and Sustainability Officer, Havila Kiestruten and Havila Voyage. As usual, you have the possibility to drop questions during the webinar by using the Q&A tab that you can find at the bottom of your screen. Our speakers will have the opportunity to reply to your questions either by typing the answer directly in the Q&A tab or answering live to your question at the end of all presentations during the Q&A session. The webinar is recorded, and the recording and the presentations of the webinar will be available from tomorrow on IA Bioenergy website. And as already said, so please use the Q&A tab for questions and do not use the chat, which is supposed to be used for greetings and to introduce yourselves. And that's all for my side. So I'll give the floor to Thomas Walsh and enjoy the webinar. Thank you.
Thank you very much. You're all most welcome to this webinar. We will be having this over the next 90 minutes, lowering hinders for maritime biofuels, identifying means to increase the use of biofuels in the marine sector. My name is Tom Walsh, and I am the NTL for Ireland on Task 39. It would be very nice if you can tell us where you're from in the chat function, maybe mention your name and also where you're from and your organization. It creates a connection, and we encourage lots of questions as we go through this webinar. So without further ado, I will pass the floor to Thomas Ekbom, who is the task leader for Task 39. Thomas, please.
Thanks, Tom, and greetings to all delegates to this webinar all around the world. I will now start my presentation. So welcome everybody to this webinar that is focused on lowering hinders on maritime biofuels. This presentation will be on challenges and opportunities for maritime biofuels, and I'm very honored to speak at this webinar before Dr. David Bauner will speak after me, who is the main author of this report. So my day job is at the Swedish Bioenergy Association, where I'm the project coordinator of a biofuels network. And my nighttime job is at the IA Bioenergy TCP Task 39, where I'm the task leader of biofuels to decarbonize transport, and also the national team leader of Sweden. So the IEA is an international organization that has also set up technology collaboration programs, so-called TCPs. The aim is here to improve cooperation and information exchange between countries. And the IEA Bioenergy is one of those task groups within a TCP. And altogether, there are 6,000 experts worldwide who represent nearly 300 public and private organizations located in 55 countries. So here you can see a picture showing the different areas with supply, conversion, and also end users where IEA Bioenergy is one of those TCPs among other areas. The members of IEA Bioenergy Task 39 during this triennium of 22 to 24 are these countries. Sweden has been the task leader, Brazil has been the co-task leader, and we will now in 2025 have Brazil as the next task leader. We also had US Grains Council as a limited sponsor, and for the next years, we will perhaps also have Australia and Greece. We have already confirmed Norway and France, so it will be a strong group of participants in this group. So the main activities and focus points for Task 39 is to analyze policy, technology, and markets with sustainable biofuels implementation. So these are the areas, and these are the different activities where we disseminate information and to make outreach to engage stakeholders. We also collaborate with other task groups and also other international organizations, as well as other TCPs and national programs. We also have a magazine that is with 3 issues per year. And the last one was featuring a country profile with biofuels production development in the United States. And the prior to that was a feature article of New Zealand. We have 3,000 subscribers, and these magazines are available for free at our website. Now, coming to the presentation. So the world is dependent on fossil fuels, and the world is also dependent on shipping. So we really rely on fossil fuels, and the shipping also stands for a significant amounts of emissions. However, there have been historical major advances in biofuels in the transport sector. We had in 2008 the first flight on a commercial jet airliner on bio-based jet fuel. And in 2010, we had the first passenger flight on biojet. We also had in 2007, the world's first train on 100% biodiesel, the Virgin Voyager. And that followed later with other trains operating on diesel. And we have in India regular use of biodiesel since 2015. Well, now the average lifespan of different means of transport are different. That means also the challenges and opportunities are different. For passenger cars, there are 12 to 17 years, and for planes, 20 to 30 years. However, for maritime industry, the large container ships, they have a lifespan of 30 to 50 years. So the conclusion is that global shipping is by nature conservative and extremely long-term. In addition, it is truly international and need to seek uniform solutions for sustainability. The question is how? Here's an example of the world's largest diesel engine in a ship. And the diesel engine is also an example of massive energy consumption. So it demands a lot of fuel. However, since many years, the shipping industry has been mainly working in the same way. And it's been conservative in a way, but in the last decade or so, there's been disruptive technologies that have come and also a transformation in the industry. So here's an example, old but new tech, where I have wind rotors or suction sails. And Airbus have made a project here that all ships chartered by Airbus would be retrofitted with these suction sails. And just recently, Maersk placed an order of suction sails on their 5 vessels with tankers. Another example is a Swedish ocean bird company with return of sails. So these sails are elongated and can be lowered so we can be passing under a bridge. And the world's first ro-ro ship with sails, and the largest sail ship ever, would be the 220 meters long Orcelle Wind. to be launched in a couple of years. This was developed by the Swedish Wallenius Marine together with the KTH Royal Institute of Technology and the SSPA. Here's another example with passenger cruise ships also adding sails. We have another example of the Swedish ferry company Gotlandsbolaget. They strive with investments to reach climate-neutral ferry traffic. So they started with eco-driving and then switched to liquid natural gas and liquid biogas in 2018, and also lowering emissions when they are in harbor to use onshore power. The latest developments has been with the Gotland Horizon and the Gotland Horizon X. These are 100% fossil-free ferries fueled by biogas and also ready for hydrogen. They also have taken part in local biogas production plant. This is all with the aim to have climate-neutral ferry traffic to Gotland by 2045. Now, the maritime sector is now changing fuels for the very large ships. We have IMO's goal of reaching net zero emissions by 2050, but that requires a switch to biofuels and e-fuels. So the new trend is for electro-based fuels that are fuels produced by electricity and carbon dioxide. Here's an example with Maersk that have dual fuel ships with e-methanol. And the global shipping consumes 260 million tons of oil per year and emits around 1 billion tons of CO2. Here's an example of a production plant that is in development in France. This plant is developed by Life and Eli's Energy. There are some 60 large e-methanol projects around the world. Those countries that are dominating is Denmark, France, Sweden, North America, and China. So e-methanol appears to be a decisive solution for reducing the sector's climate impact. And the global projects for green methanol are growing rapidly. Here are 4 examples of large production plants in Europe. Well, what is the cost then for e-methanol? Here is an example with a study that was made by Ilkka Hanola for the IEA using calculation of different costs of assembling the CO2 and then the cost for the production with synthesis, electrolyzer, and then electricity. And it can be shown here that the cost of carbon dioxide is crucial to lower the production costs. And if you can have a high concentration source of CO2, the production cost would be some $35 per gigajoule. There is also a trend now. There's a rollout of green methanol bunkering all over the world in different ports. Here's a recent example in November at Shandong port in China. So these ports have traditionally used bunker fuels that are fossil-based and now adding methanol as an alternative fuel and a bridge to green methanol. Another trend is that large oil refineries all around the world is retrofitting the oil production for products like gasoline, diesel, and SAF and heavy oils by adding biomass-based feedstocks. And the products are called HVO. And then these oil refineries are very large in scale. And here's an example in the United States with the Phillips 66, the Rodeo biorefinery in California, that's transformation, the whole oil refinery to be completed with biomass-based feedstocks. And the operation of this large-scale oil refinery with only biomass feedstocks started in Q2 in 2024. And the price was some $1.25 billion. So the global shipping is changing. It's in the midst of transformation to reduce emissions and to achieve climate neutrality. However, we all can make our own choices. And perhaps if you want to commute to work and you have rivers, you can use windsurfing. It's environmentally friendly and climate neutral personal transport. This ends my presentation. Thank you.
Thank you very much, Thomas. That's certainly, I think we'll all start windsurfing to work. It might be a bit cold some time of the year. We do have one question in the that has come up there. Maybe I can. It's from Anton, and I can just pass it on to you. Based on a working paper of the Maritime Shipping Association, 47% of transport can run hydrogen right away. How to save limited bio supply to longest distance freight as they need it for energy density. I don't know if you want to make any comments on that.
Yeah, I think that all of those solutions are necessary to achieve a transformation. And what we can say today is perhaps not what is tomorrow. So if there is a cost or if there's a technology issue that we have today, we need development, we need research, and we need deployment to show that it can work. And I think that by time we will find the solutions and also the right measures.
That's great. Thanks, Thomas. And just to say, we have people literally from all over the world, US, Germany, Denmark, Mexico, Puerto Rico, South Korea, China, France, Portugal, South Africa. So all the continents are covered. So maybe we can go on to our next speaker then, Dr. David Bowner, if you would care to take the floor, and you'll be delving into the nitty-gritty of the report itself. So we look forward to your comments.
Thank you very much, Tom. I'm sharing my screen here. Let's see if I succeed with that. Have I succeeded? Yeah, I think so. My name is David Bowner. I'm the CTO of Renetec Bioresources of Ireland, and I will now guide you through a brief summary of our report, which I encourage you to read, obviously. It will be available online at IEA Bioenergy by the end of the year, after it's passed the leadership of the task later on now in December. So I look forward to sharing those results with you. And now I will try to talk through a few talking points regarding the preliminary results. We've worked with a reference group. I will take you through a background, look at the outline of the report, and then go through more or less the value chain of different fuels, looking at incentives, and to get to the core of the report, how we can overcome the barriers that have hitherto been conducive to having a total fossil fuel dominance for supply of fuel to the maritime industry. We'll also look at energy efficiency and e-fuels as part of that, as Thomas already showed us a little bit about. So as regards our report, we started out by forming a reference group and interviewed several of those, and then we've added interviews as we went. So if you see here the value chain in front of you as a value line, if you will, with sourcing, processing of fuel, distribution of fuel, which is obviously an important part, and not the least, its use. We have representatives in both the reference group and among interviewees from Södra research institutes, the Methanol Institute, and looking at methane and ammonia and so on, distributing fuels also by means of Södra, Kolabit, and Fossil-Free Marine, and not the least then coming into the harbor. Singapore Harbor has been very helpful in providing information about their ambitions and ways forward to guide the development. Also Maersk and Havila, who will speak later today, and Stena Teknik. So that has been an interesting journey, and has also shaped the report, both the formulation of it and also the content and so on. So the main challenge is that we have to go from a very high more than 97% of fossil fuel-driven industry today, literally driven, which will come down to zero in only 3 decades, or it's even less than 3 decades now. And what's interesting here is that if we talk about volume, the volume of fuel that we will use until we have decarbonized is to the left of the dotted line in the graph, meaning that if we manage to decarbonize earlier, like the blue line suggests, we would save a considerable amount of carbon dioxide emissions. So there's all the reason in the world to decarbonize faster rather than slower for the sake of reducing the emissions of carbon dioxide to air from shipping. And one important factor in this work is also that 40% of all fuel is calculated to be used for shipping fuel, which is a bit of a, it sounds difficult to comprehend, but that means that if we manage to regionalize and make the supply of fuel closer to where it's finally being fueled into the vessel and used, we will save not half, but close to half of all the fuel only by reorganizing supply. So if that supply also is renewable, sustainable, that means that we have done our job. The report, which soon will be released, is outlined as follows. We've introduced the problem and our means of looking at it. We're looking at the history of industry, how marine fuel is used today. And then chapter 2 is an overview of the state of the art, going by means of the value chain from sourcing, production, and fuel use again. And then in chapter 3, we're looking at different kinds of means to overcome barriers for biofuels. We've looked at the system level, regulation, biofuel production, both regarding drop-in fuels, methanol, as Thomas mentioned, and e-fuels, as Jörgen will talk about. Also, the distribution of use of biofuel, as Lasse Wangstein will talk about after me. And importantly, energy efficiency measures, including sales that Thomas mentioned, but also hull cleaning and other measures, and maybe the reorganization that we discussed as well, will play an important role in reducing the demand for biofuels, which then again will make them more viable. We also look at the need for investment and end the report with 2 case studies, one on looking at the entire value chain as a solution for New Zealand from pyrolysis of biomass, of woody biomass. And we look at MPA Singapore, the largest bunkering port in the world by far, as you will see, and how they are working towards this goal. So I invite you to read the report once it's open, once it's out in less than a month. We end by looking at the roadmaps, which I will also briefly show today. Well, if you look at the systems level, we, being the shipping industry in this case, can be viewed as one system and part of the transport system of the world, but there are also other systems. And more importantly, for this purpose of this seminar or webinar, that we are one of the means of transport. There's shipping, there's road transport, there's aviation. And in the case of use of fossil fuels and biofuels, biofuels mostly, we can also look to the chemical industry, which is also trying to decarbonize and will also look increasingly to biomass-based fuels and sources in order to produce their products. We also are dependent on economic growth and the levels of international trade that we've seen been very much affected by global affairs, such as the war on different fronts, and the level of international trade depending on everything from pirates to the price of fuel. The strength of climate policy, the carbon price, the availability and price of fossil fuel, the availability and price and cost of biofuels, and the resulting greenhouse gas emissions will all play a role in how strict the measures can be and how strict they should be and what we can do. So you see here different scenarios with high and low international trade leading to different levels in these different categories, where obviously the greenhouse gas emissions is the key one to watch. But in short, shipping is competing. It has to be competitive in terms of what they pay for the biomass sourced fuels in order to get them, basically. So this sourcing, in short, can come from either by using bio-based CO2 for e-fuels, or for using biomass rich in oil and fats, or used rich in sugar and starch, lignocellulosic biomass, or different kind of mixed resources, such as glycerin from biodiesel production, methanol from its different feedstocks, biowaste, and so on, that could serve towards different means of production and for different fuels. We can note, for example, also that regarding sourcing, limiting ourselves to sustainable sourcing for biomass production, biofuel production, sorry, there's quite a few different kinds of sources of biomass which are allowed according to this is the European listing, Renewable Energy Directive 2 and 3. You can see it's about a dozen and a half of different types of waste that you can use that are available in different amounts across the world, and they all need to be certified also in order to serve as means for or feedstocks for biofuel production, sorry. Arriving to the biofuel, then we can either use the established methods and look to innovation. Here's an example of innovation where we, by producing biogas and adding a catalysis step, can reform CO2 and methane to methanol with or without external additions of more hydrogen through electrolysis. The system also works without electrolysis, which obviously reduces the capex and opex a lot. Electrolysis is fairly expensive. So this is one innovation that also makes anaerobic digestion and the organic fraction of organic waste from cities, households available for shipping fuel, but also for fuel and biofuel for other sectors. By different means of production, then, we arrive at different kinds of biofuels that have characteristics more or less similar or in the range that makes them useful also for shipping. We can see, for example, that biocrude has about the same volumetric energy density as the fossil oils used today, whereas the biodiesel has a lower volumetric energy density. So then there you have to compensate by fueling more often if biodiesel is used, whereas HVO has a bit higher volumetric density. Now, going into production, we can see that this innovation that I mentioned one example of before has different steps. It's not a matter of just starting some kind of innovation process and expecting to arrive at a result defined time thereafter. But you start off at a beaker level where you can make a very little amount, showing that the process is okay. Then you invest millions of euros to reach the bucket level where you have a slightly bigger pilot or a pre-pilot installation that shows that it's feasible to have a larger scale. To reach the barrel level requires yet another millions of euros in investment. And then when you want to get actually to use the fuel in commercial use, to get to the bunker level, that's a very large investment and represent an industrial level engagement, which is with totally different partners and totally different levels of resources needed. So this is a complex area in itself that needs to be monitored and supported on the different market where we want the regions to be autonomously producing enough to supply the region. Another area which is very important to overcome the barriers that we see today is regulation, where IMO, the International Maritime Organization, is leading. we'll come back to the different methods used, but it's about having an efficient ship and a low carbon fuels by different design measures. There's since some time obviously been a discussion on reducing, for example, sulfur in the marine fuels, which means that there's also a discussion on cost effectiveness when you take for transport, which in turn then has already put focus on energy efficiency in ships in terms of hull cleaning and sales, as we have discussed. There's the emission trading system in the EU. EU also has a maritime directive regarding the percentages of biofuels and carbon emissions from maritime fuels. There's a taxation directive with a bunker fuel tax. There's a revision that we've already looked into briefly. And there's a sustainability and certification on carbon being under development, which contributes to lowering the hinders for biofuels as part of decarbonization of shipping. So RED 3, for example, states that you will have 29% of the energy used should be reduced in greenhouse gas intensity, and subject to several regulations. There is also already obviously some production of biofuels, and looking at the regional side of this, we see that some areas produce more biodiesel, some areas produce more bioethanol, bioalcohols that could be used for as part of shipping, and that needs to be balanced better if we are to reduce the fuel transport as part of the energy use and focus on the transport of goods other than fuels. Today, bunkering is very much based on price. As you can see here, there is a clear winner in the amount of fuel that is bunkered in the world. Singapore is strategically located between China and India, and China and Europe, if you will. And obviously has a very important role. You can read more about that in the report and the work forward. And when you create a market for biofuels, there's a number of challenges, opportunities. This table shows you a core of the report along the value chains, and also looking at the technical and economic means to overcome the barriers, such as matching supply and demand. We must look to regional profitability and by means of regulation and other types of incentives, and not the least by innovation to make sure that there's a competition with marine fuel with that from aviation and bioplastics markets, and adhere to the IMO roadmap. Energy efficiency and e-fuels that Jürgen will talk about later is extremely important as we go by, because to the extent that we can save the amount of fuel, and this is like tenths of percent, this is a very large share of the cost base for purchasing fuels that can be saved by means of sales and so on, and the sales are there year on year and provide the benefits, whereas the fuel has to be fueled up every time you bunker. So that's a big opportunity to look at, and there's a number of measures that you see here to achieve this. You see also the means here, including carbon capture. Sales is a reality, as was pointed out, not only from windsurfing, but from actual bigger ships as well. And several ships are now fitting these sails, and they can see 7 to 10, and I've seen numbers up to 14% of reduction in fuel consumption for a given transport relation, which is obviously very important. Another means to understand the future is to look at how vessels increasingly are prepared to use biofuels and to be more efficient, and e-fuels, of course, also. And as we can see here, LNG is the first contender for, I think, for shorter transport relations of ships, whereas and then second is methanol in the present fight for number 1 and 2 in what kind of fuels will replace the non-drop-in fuels. In addition to that, obviously, we have drop-in fuels that Thomas mentioned, which obviously comes at a lower cost of implementation other than for bunkering, whereas they can be used in regular ships today that are today use fossil fuels. Towards the end of the presentation here, then, we look at different outlooks coming down to zero in fossil fuels for shipping. And here is a recently presented transition outlook by DNV, where their biofuel scenario, they have several, I should say. So we'll see where the future will lay, but this is the biofuel scenario. And as you can see, biomethanol and marine gas oil dominates. There is a rapid phase out of fossil methanol. So there's a lot of methanol ships coming, but very rapidly, the little brown dots here up by the 250 mark get out of our way very quickly in only 6 years, according to this outlook. Whereas the fossil LNG, there are a lot of ships, and LNG is cheap, so that will take a longer time to move out of the way. But possibly there could be a sorry, I should stop there. But near shore, you see nuclear to supply power for electric. We'll see if nuclear will be that choice, but electric anyway. And CCS, carbon capture and storage, specifically bioenergy CCS for bio-LNG and bio-marine gas oil, for example, through pyrolysis. And for the remaining fossil fuels that will be on the market closer to 2050, they could also use carbon capture and storage to get rid of the emissions to air of CO2. To understand then how to overcome these barriers, we can look to some conclusions. Anybody aiming to produce biofuel should look at the availability of feedstocks and the fuel on different markets, the scalability of the production, and the sustainability of the operations, that they are energy efficient in themselves, and that the end result works well for the along the value chain. The innovation from beaker to bucket size production, as I mentioned. A very important part, which perhaps I should have focused more on, is that some harbors and some other organizations are coming together in what's called green corridors, where the prerequisites for fossil-free shipping is taken care of by these ports and these intermediate actors, which through alliances expand the market for a given transport relation, for example, between Singapore and Rotterdam is one example of that. We should also know that regarding production, and for much of the innovation around decarbonization of shipping, 95% of these projects are sitting before the decision to invest. So that there's a lot of work to do in terms of preparing those decisions and funding the deals. And then the implementation phase, the industrial phase, where funding, in-house R&D and engineering, like a large-scale rolling out of bunkering and transport and production capacity to get to the bunker level. And we've already started regarding the drop-in fuels, which obviously then is the lowest hanging fruit, where 1 million tons already has been, or more, has been bunkered already. 1 million tons was bunkered in 2023, and now it's already more. And the orders of dual fuel ships, as we saw in the future fuels slide from IMO, are increasing. And everything regarding investment is doubling. So the world is definitely moving on, and we will see a lot of investment in this area. Thank you very much.
Thanks, David, for that comprehensive input, and I know there's quite a few authors to that report, some of whom are on the line as well. So we thank everyone that has contributed very actively over the last 12 months on that effort. There's a question here from Cato Sanford. It looked like you were advocating following the EU's lead in designating certain biofuel feedstocks as sustainable for scale-up and restricting the use of biofuel based on this list. How would this get enacted in policy? Who would be in charge of drawing up the list of sustainable feedstocks? How would it be monitored on a global scale? We'll just take that question. We'll take the other questions at the end of this.
Yeah, you want me to? I can try to answer. I mean, this is fairly straightforward in that many ports and the major ports in the world, I think all of them that was listed in that slide before, have subscribed to the IMO regulations. And in that case, you have to have accredited and certified fuel sources. So in the case of the IMO ports, so to speak, they will deal with this. And there's also already a good system for limiting the feedstocks for biofuel to the list that you saw of the EU RED 3. There will of course be other transport as price of fuel goes up for the sustainable fuel. Obviously, there will be people that will try to go around these regulations, and that has to be looked at how that could be addressed. But for the main ports, that I think that will come around. Thank you.
Okay, thanks, David, for that. So the next speaker is Jürgen Jacobi. Jürgen has a PhD in energy technology from the Royal Institute of Technology in Stockholm in catalytic combustion for gas turbine applications. He has worked in the energy sector for 25 years, mainly in the thermal energy sector. He was test leader for Vattenfall's CCS program in Schwarzpumpe in Germany, testing the oxy-fuel combustion process for lignite-fired boilers. He has experience both from the gas turbine and biogas sector, and now has worked for more than a year with European Energy Sweden to develop a e-methanol production site in Sweden. And that's aiming at scale of 100,000 tons. Welcome, Jürgen. We look forward to your input.
Thank you very much for this lovely introduction, Tom. You make me sound very old. And thank you very much for this opportunity to present what we are doing here at European Energy. Now, let me share my screen. And I hope this is working now. Tom, could you just say yes, please, if you see my screen?
Yes.
Thank you very much. Excellent. Great. Yes, thank you, and good morning, good day, good afternoon, good evening, everybody who is listening. I'm very grateful for this opportunity to present what we are doing in the field of e-methanol production and trying to solve the chicken and egg situation with availability, scalability, and of course the economy of renewable fuels in the transport sector. And I fully agree with the previous speakers about the challenges and the situation where we are in today. I'll keep it short. We are not that well known, European Energy, as a company. We're about 850 people. We're a Danish company, and we're kind of a middle thing between a project developer and a power utility. So we do have own production facilities to generate renewable electricity in the form of onshore wind, offshore wind, as well as solar power. We are developing power-to-X plants, and I'll dive into that later on. We do have in-house competence for carbon capture and as well also for battery storage. But it's fair to say that all the projects that we develop, some we do sell off. Hence, we're kind of a middle thing between a utility and a pure project developer. And I will not go into detail with all these pictures in here. The only thing I want to highlight with this picture is, and I think vertically integrated is the term that is being used today. As a company, we do have a lot of in-house capabilities. We do have our own EPC department, we have our own construction teams, and we also have our internal asset management operations. That does not mean, however, that we are not interested in partnerships, of course. So please keep that as well in the back of your head, that we are open for partnerships to jointly develop projects in the green transition, if I may call it like this. Just a quick map where we are. We're called European Energy. We have the majority of our people, of our 850 employees within Europe, in those countries highlighted here on the map. But we do have activities in the United States, in Texas to be precise, in Brazil, as well as in Australia. And the reason for that is simply we have identified those markets as very attractive for the generation of renewable electricity, but also to develop power-to-X projects for a variety of different reasons. So we're a little bit all spread all over the world, but there's still many, many countries left for us to grow into, of course. Diving into the power-to-X department, or the e-fuel challenges, those are the main roadmaps that we have developed as a company. Of course, when we start from left to right, and we heard it before, producing hydrogen is a key issue if you want to produce any renewable hydrocarbon fuel. While production of hydrogen is relatively simple on paper, it's quite tricky in reality, and for sure it is relatively costly also in reality. We are, however, in a good situation to bring down those costs, which I think is a key success factor in order to come to the next step, so to say. With our 2 power-to-X sites that we have in operation, one is in operation, one is being commissioned, where we will have the possibility to test and develop different type of electrolyzers to produce the hydrogen. As you can see on the top of this slide, we also need biogenic carbon dioxide. Sweden, of course, with all the paper and pulp industry present, is a large emitter of biogenic CO2, but it's still emitted. So capturing the CO2, again, it's quite a big chapter. It costs a lot of money. And we're looking at this beaker to bucket step that David showed us. I couldn't agree more with that. Capturing CO2 is technically feasible, but it's costly. It doesn't come cheap. Once you have the hydrogen and the carbon dioxide, you can produce your e-methanol, which you do. You can upgrade this to sustainable aviation fuel if you want to, or you go directly into the transportation sector, which is the main route that we are following. We do have a hydrogen facility as well in Denmark, where we produce hydrogen at a relatively small scale, and I'll dive into that in the following slides. That hydrogen is then going directly to the clients that we have nearby. And here is that's an aerial shot of the hydrogen production facility. We are in Mode, which is hardly known to anybody. We're on the western coast of Jutland, of the main country part of Denmark, so close to the city of Esbjerg on the west coast. What you see here is a pure hydrogen production facility, and I hope you can see my mouse moving here. This white cylinder in the middle of the picture, this is the alkali electrolyzer from a Danish supplier called Stistal. That's public domain info, so I can say it. You see the auxiliary equipment around it for the power supply, the gas treatment, the polishing, the control systems. This big building in the middle, that's the hydrogen compressor. And from the hydrogen compressor, we fill these truck trailers from where we ship the hydrogen or we truck it, I should say, the hydrogen for about 5 kilometers to the port of Esbjerg, where we have an industrial client who is the receiver of this hydrogen. It's a relatively small unit, and I have some technical numbers on this slide here. This installed electrolyzer has a capacity of 4 megawatts at the moment, but the site is prepared for 2 additional electrolyzers. So once all the 3 units are up and running, we're going to have a capacity of 12 megawatts. Now that sounds relatively small compared to many of the projects that are being advocated all around the world. Jumping back into this picture, I guess you get an idea, an impression of the complexity and the size you need. So producing hydrogen is feasible. It's done all over the world. It's not hocus pocus or Harry Potter magic or whatever, but it doesn't come cheap, and it's complex machinery that you need. This is the key message that I want to bring forward. It looks simple on PowerPoint. In reality, it's a little bit more tricky. The beauty of this site is that we have decided that we're going to test 3 different types of electrolyzers, and I will jump to this next slide, or to save some time. We're testing and developing together with our suppliers different types of electrolyzers, and this is for us as an operator and a power utility of key relevance, that we have a very steep in-house learning curve to get the experiences we need to have in order to be able to design the next facility in a better way. We have decided on electrolyzer number 2. I honestly don't know who the supplier is, so I can't tell you. I really don't know. It's been communicated it will be a PEM technology, also a proton exchange membrane electrolyzer that we're going to install there. This will have about 400 tons per year of capacity compared to the 270 from the alkali one. And supplier number 3 is to be decided. I don't know yet, but it will give us, as an operator, a unique possibility to test different technologies and see how well does what work. We are also going to test, and we're going to run the electrolyzers at a varying load profile. We learned already that the electricity price is a key factor in the price of the hydrogen. So when the electricity is very expensive, we're going to produce less hydrogen. And when the electricity is cheap, then we can ramp it up and produce more hydrogen, because costs are an important issue here. And we are very well aware of the fact that we need to bring down the costs for any e-fuel in order to make those fuels compatible in a global market, which we are, in which we are. Now, moving along, this is our e-methanol plant that we have built. It is ready. It is being commissioned at the moment, so it's not yet in operation, but it's the mechanical construction was finalized a few weeks ago. We have all the permits, and we are in the commissioning phase right now. This is also located in the southern part of Jutland, about 20 kilometers north of the German border, and about, I think it's like 15 kilometers away from the city of Abenra, or Obenro, in case you know it. So it's southeastern part of Jutland. What you see here in the foreground, the dark gray buildings, those are 3 17 megawatt electrolyzers. We have chosen Siemens Energy as a supplier. Those are PEM electrolyzers. Main reason to go for PEM cells here was their capability of fast ramping up and down. Behind the electrolyzer buildings, there's a long building with the white rectangles on the roof. That's the hydrogen compressor building. And behind that, you see the methanol production line number 1, and in the very background, methanol production line number 2. Towards the horizon, you see the solar PV arrays, which is one of Scandinavia's largest PV parks that we own and operate ourselves as well. And basically, we can run this facility on 100% solar electricity when the sun is shining. Of course, the sun isn't shining all the time, so we need to be connected to the power grid as well. But we do have the electricity available to run this plant. On this slide, I have some more technical figures on this one. We're not yet at the 100,000 tons, Thomas, that you also showed us in your list of e-methanol facilities. With this plant here, we're going to produce, we think, around 32,000 tons on an annual basis. It is designed for 42,000, so we can produce a little bit more. Again, the cost of electricity comes in here as a key factor in terms of bringing the cost of the methanol down in the end. We need a lot of electricity. That's also a really important issue. So producing e-fuels does require a lot of electricity. It's just a fact of the technology as it is. We also need biogenic CO2. In this case here, we're going to use about 45,000 tons of CO2. That CO2 comes from a biogas plant about 25 kilometers away. So we do have truck transport to get the CO2, and we have truck transport for about 13 kilometers to the harbor in Obenro to ship out the e-methanol. Of course, the closer such a facility is to a CO2 source, the closer it is to the power grid, the closer it is to the harbor, the closer it is to a water source, you get the picture, the easier, the better. But that's a puzzle that is not so easy to solve, I'm afraid. Those facilities, both the hydrogen as well as the e-methanol plant, are connected to a district heating network that we have in the area. We do have a lot of excess heat at quite high temperatures as well. So this is an additional means of system integration of the e-fuel facilities in your local community, which is quite important if you want to build something. Yes, here I have it. I knew I had one slide more on our clients, and this is the connection to the shipping industry. Our main client is Maersk, the Danish ship operator. They have a vessel called Laura Maersk, which is a container feeder vessel going from Rotterdam to other ports in Northern Europe. And that vessel will run on the e-methanol that we produce in this facility. Great success story. Really, really interesting. And Maersk has very ambitious plans to decarbonize its routes by using e-methanol. Very interesting. I find as well that if we look outside of other sectors than shipping, for example, we sell the e-methanol to Lego. And now I'm talking about the Lego company who makes these plastic toys that I guess most kids use all over the world to build whatever. So they're going to use it for their low carbon plastics. And we also sell the e-methanol to a pharmaceutical company, Novo Nordisk, which is going to use the e-methanol for their plastic packaging for their products. So besides shipping, which is the focus of today's webinar, there are lots of other sectors which I think will increase their use of raw products, if I should call it like this, in the near future. And this is a key message for us in order to find clients. Because here's some more pictures from the building of the facility, and I'll jump onto this one. Because if we look into the next step in our development, we also want to build an e-methanol facility producing 100,000 tons a year. We are quite close to an FID, and I would guess that we take an FID for the next facility at the beginning of next year, so beginning of 2025. That facility will most likely be in Denmark. Those are the two sites where we have come the furthest, and you see like an artist illustration how it could look like. We do put a lot of focus on finding clients. It doesn't make sense to have this billion investment to build a facility if you can't sell your product. So we do put a lot of focus on talking to shipping companies, to the chemical industry, and to many different sectors, and also to the SAF sector, so sustainable aviation fuel, trying to secure offtake agreements. And as soon as we start talking agreements, price is an issue. So again, we need to bring down the costs of the methanol. We need to bring down the costs for the hydrogen, or get somehow hold of cheap electricity in order to make our product being economically viable in a tough market. We do see the demand. We have lots and lots of talks with many different companies. So we feel quite confident that there will be a significant increase of e-fuel facilities occurring all over the world. And then this is my last slide. And here you see the markets where we are focusing at the moment. Now, this picture may change, of course, over time, but we have progressed to different stages in different countries. We have secured land in the United States, in, I think, Port of Victoria in Texas, if I remember correctly. We have secured CO2. We have developments in Brazil that are very interesting, as well as Australia. And me being Swedish, working in Sweden, I, of course, hope that the Swedish plant will be the first in a row after the Danish plants that we have. We do look into Lithuania and Spain and Portugal as well. So what I want to say with this picture is that the demand for e-fuel is definitely there. It's an issue of getting these projects up and running. They cost a lot of money up front. It is a tough negotiation with clients regarding the price of the methanol or whatever you have. But the pressure from the society to decarbonize transport and many other products will most likely increase in the future. There will probably be some dents along the way, but as a general rule, there will be more and more demands on sustainable transport issues for whatever product we're talking about. And this is a value chain of which we want to be part of. And with this, I conclude my presentation and I stop sharing my screen.
Thanks, Jorgen, for that fascinating input. I think we have a few questions for you, actually. I'll just take two now for the moment. Different industries will have different abilities to pay for fuel, and at this stage of commercial development, PTX will be out of budget for many. Who do you see as being the main off-takers in the next 5 years? What about 10 years? And then linked to that question was another one which they were talking about, what is the capex for the Danish e-methanol plant? You may not want to answer all, but answer what you want to answer, so to speak.
The e-methanol facility that we have built, the one that I showed you, that cost roughly 1 billion Danish kroner around in that area. I don't know if it's 1,100,000 or 1,150,000, but it's roughly 1 billion Danish kroner was the investment cost for this facility. The second question was regarding the clients. As you can see from that list of clients that I showed you, those are big companies. Novo Nordisk has a turnover at the size of the Danish BNP from the entire country. That's a big company. Maersk being one of the largest shipping companies in the world, that's a big company, and so is Lego, actually. So I think a key issue for the moment in finding clients for us is finding clients who have the financial muscles to pay a premium for the green fuel. And they must have a sustainability vision to being or having the wish to be part of the first movers, so to say. It doesn't come cheap at the moment. That's just the way it is. But of course, with all new technologies, we believe that the price will decrease over time, of course. And there are lots of different factors that come into this price picture.
That's great. Okay, I'm sure we'll have a couple of more questions at the end of the session. So thanks, Jorgen, for that. And now our next speaker is Lasse Wagstein, who is the Chief Communications and Sustainability Officer for Havila Voyages. Having been there for 3 years, he has 20 years of experience in the travel, trade, and transport industry. He also has experience as a communication advisor for the wholly owned state company Avinor, who operates and owns and operates the majority of Norwegian airports. And he is the head of communications for Vålerenga Football Club in Oslo. So Lasse, the stage is yours. You are most welcome.
Thank you so much for introducing me, and thank you for having me on this webinar. I will try and share my screen, which was hopefully a success. I work for a small Norwegian shipping company called Havila Voyages, or that is our brand name. We are called Havila Kystruten, which basically means coastal route, because we operate the Norwegian coastal route, historic coastal route, 130 years and counting, starting down south in Bergen and turning in Kirkenes up north by the Russian border and then down again to Bergen. This route is owned by the Norwegian government, so we are under a state contract. We own 4 of the ships and operate 4 of the ships. It is total 11 ships operating this route under the contract. The contract runs until 2030, with the government having an option for additional year. Our founding father and chairman of the board and still majority owner, Mr. Per Sævik, now soon turning 84 years old, stated when he started this company that we are sailing in the world heritage, so should the generations to come. And that is basically the backbone of our operations, is to find the best possible solutions to reduce our footprint in the areas that we love. And quite frankly, we operate in some of the most beautiful areas you will see in the world. The Norwegian coastline is unique, it is varied, and we operate 365 days a year. We are basically a hybrid ship. These ships aren't very big. They're about 16,000 gross tons and can carry up to 640 passengers. They are a ferry for the locals. They are a cargo ship for locals and companies, and we are a cruise vessel. So basically, we do everything, and we do it along the coast. We do not go out to international waters. We are in Norwegian waters the whole time. And it is a timetable, it is a schedule. So we have to be in port A by that time every day. And we are willing to claim that we have one of the world's most environmentally friendly cruise fleets. Today, our ships are run on LNG plus operations, which is basically LNG and large battery packs. We cut our CO2 emissions today by 35 to 40% compared to the reference numbers from this coastal route from 2017 with diesel-driven ships only. With biogas in the future, we can be carbon neutral, meaning reducing up to 90% of our CO2 emissions. At delivery of our first ship, Havila Capella, who also won the Next Generation Ship Award during Nordshipping in 2022, we had the world's largest battery packs ever installed on a passenger ship. There has been at least one cruise ship that have a bigger battery pack, but they are not able to operate the ships up to 4 hours with zero emissions sailings as we can do. So we operate the World Heritage Fjords of Geirangerfjorden in Norway, zero emission, which was the requirements from the Norwegian government from 2026. Of course, in September this year, they went back on that and postponed it to 2032, which we find, well, we think that's a scandal, but that's for another discussion. Our NOx and SOx emissions are reduced by 90% by these operations. And of course, when we designed these ships, and all our 4 ships are identical and they're brand new, we have an energy efficient hull design. We are hydrogen ready. I will come back to that. And on board, we produce, or we serve locally produced food, which also cuts, the way we serve it cuts food waste by a lot. So environment sustainability is, like I said, the core of our business. And we, of course, use heat recovery from sea and engines to reheat the ships, so we do not have too much excess heat. As I said, these ships are actually plug-in hybrids running on liquefied natural gas today, maybe in liquefied biogas in the future, and batteries. By plug-in hybrid, I mean that we can actually charge the batteries in port. Not many other passenger ships can do that. They are hybrids, but they charge the batteries by the generators only. We can actually charge them in port using clean Norwegian hydropower. Of course, when the infrastructure is up and running, we hope to be able to charge the batteries more to utilize them even more in daily operations. And we do utilize them in daily operations, just as your hybrid car. We get more power from the batteries when needed, and we charge them when we have excess power to spare. We try to run our generators at the set load the whole time to optimize our fuel consumption and then again reducing our emissions. So we are on the journey towards zero emissions with our ships. And that starts today with LNG and batteries reducing 30 to 40% CO2. Then the next step for us would be maybe from next year or the year after, start blending in liquefied biogas. They have the same properties, as you guys know, as the liquefied natural gas. So we'll start blending it in and eventually going on biogas only with the batteries, then being carbon neutral. Then down the line, our ships are also prepared for hydrogen. That would require a refurb, but the systems on board, the electrical boards and everything is ready. So we'll probably that we attach to the ship during a docking. We have biannual dockings of 11 days. So we'll be probably able to connect that ducktail there and then carry hydrogen in containers that we swap with our own lifting mechanism. And of course, we will still carry our biogas tanks and the batteries and use them as redundancy and in case something happens with supply and demand, of course. So basically, with 4 ships as of today, and have in mind we have ambitions to grow on the coastal route in the future, we want to have maybe 3 or 4 more ships in the next tender. Then again, if we do not win, these ships are designed to be able to be converted to expedition cruising. So a lot of the designs on board has already prepared the ships for future use if we do not win the contract. So with 4 ships in operations, our power need is about 300 gigawatts per year for 4 ships. We need predictability and availability along the coast to be able to reduce our emissions even further. So that means infrastructure, bunkering, charging, and it has to be economically sustainable, both for us and, of course, for the producers and the local areas we operate in. That is our needs. We need this, and we need to, be able to succeed with this. Our authorities, at least in Norway, must signal requirements in the next tender right now. We hope the next tender is presented in 2025. They must signal requirements. Also, when it comes to reducing the CO2 emissions, it is today 11 ships operating this route. They can be a lighthouse to guide us towards reducing the emissions on the Norwegian coast. And also with requirements, they can create a competitive situation and also the development of technology. And what criteria should it be in the tender beyond price? Should it be carbon neutrality with biofuels? That must mean requirement for certifications. We think, at least the biogas we want to use, should be Norwegian produced from waste, like fish farms, farming, food waste, etc. We cannot buy biogas produced in Brazil, to make an example, that is carried to Norway on diesel-driven tankers. That kind of defeats the purpose. Development of infrastructure, I talked about that. That is essential. We have to ensure focus on the development of that. And of course, we need incentives for the green shift. The harbors need incentives, producers and suppliers, and users and operators like ourselves. Because, like I said, we are operating in areas we need to take care of. The nature we showcase to our passengers every day is not our nature. We borrow that nature. We loan it from Mother Nature. We have to be sure that we take care of that. And like I said, I think our chairman of the board said it best. So should the generations to come. So that's why we are trying to find the best solutions that we can live with down the line and in the future, heading for zero emissions. All right. Thank you.
Thanks, Lasse. Thanks for that input. And we have seen the full value chain now from the various speakers. So I think that's very interesting. There's a kind of a general question here, and maybe it's from Alex. He says, I feel the overall idea is to circulate all the carbon we've extracted from fossil fuels over the past centuries and combine it with hydrogen using renewable energy. Hopefully we have enough. However, with human activities continuing to increase, how can we estimate and calculate whether we have sufficient carbon and renewable energy to sustainably balance our future needs? So I don't know if that's a question for Jorgen, or Thomas maybe wants to comment as well.
Let's see. Yeah. That's a tricky one. Sufficient carbon and renewable energy. I think there is for sure sufficient carbon available globally. The issue will be how to capture it. So getting the technically available carbon back into the value chain, I think that is a challenge. Renewable energy to balance the future, tricky one. Of course, I hope so. I do not know. I hope it will be possible. I do have hopes that, especially the the countries that are becoming developed, that they will skip the fossil sector and jump right onto the renewable sector, as we see already in quite many countries happening. So I think there's on a global scale, but now I'm really speculating, so please don't quote me on this one. So I do believe that the general global understanding of the climate issues that we have will drive this development. Maybe not at the pace that we need it, but I think it is happening, and we see lots and lots of projects globally all over the place. So, and I'll stop here because I think I'll start to ramble a little bit. Maybe
Sure. No, it's okay. It's good.
I could just add just one sentence on Alex's question there. I mean, if you want to circulate the carbon that has come from like the fossil fuels into the air, the best way you can do is to plant a tree, and even better to plant two. You will have biomass for biofuels, and you will literally take out carbon dioxide from the air. So plant to biodiversity and planting more plants is the short answer to your question, I think. Thank you.
And David, there's a question here. Which type of drop-in fuels were consumed in 24? This was from Cyril. I think that was when you mentioned the 1 million tons during your presentation.
It's mostly in the form of B24, I think, and B16 or something like that. Thomas can help me, but it's I think it's predominantly biodiesel or an HVO. Sorry, is that true, Thomas?
Yes, that is predominantly HVO.
Okay, then Camilo from Brazil has a question. Given the significant opportunity to decarbonize the existing fleet of vessels in the coming years, there seems to be a bias towards certain accepted technological routes. Biofuels such as biodiesel present a viable option that can immediately be utilized in ship engines. Series companies are all certified according to international standards. In your opinion, what is still lacking for biofuels to be widely accepted in the maritime sector? I think it's kind of a general question. So maybe Thomas, David, you want to comment on that, yeah?
Well, it's true in a sense that biodiesel is a drop-in fuel that it can be used right away, especially if it's an HVO, because it's primarily identical to the marine gas oil or a finer diesel oil. However, there are a lot of other regulations, for example, the SECA, and also with NOx, and that leads to some companies towards cleaner burning fuels like LNG, LBG, and also methanol. And as these are also available in many ports now, they are looking for those, actually also for a low cost alternative to the heavier, the larger cost for the ultra low sulfur fuel oils, but also in the end to talk about sustainability and to maintain their customers in the future.
To develop a market for biofuels requires that the cost is on par. So you have to make it a little bit more difficult to fuel up with fossil fuels and against regulations and incentives. And you have to develop all the different fuels like the HVO, the drop-in fuels, and the e-methanol, methanol, improve the ships. I mean, so the sales, I was going to say, and also the bio LNG also, so that there's alternatives for each shipment, each shipping relation, and that the cost of using fossil fuels gets higher, so it's more attractive to use the biofuels.
And I think this is a question for you, Jürgen. Does the test plan to test the photolysis, also the most expensive, it might be good through ease of system? I think it relates to your talk when you were speaking.
Who was
that? Was Anton brought up that question.
I have to admit, I do not know what photolysis is.
Electrolysis maybe meant to be, is it? Mm-hmm.
Yeah, if it is electrolysis, then I know. Yeah. Photolysis is something new to me. I'm not sure I understand the question correct, but what we're going to test at our 2 plants is different types of electrolysis, so different ways to produce the hydrogen. Okay, optical water splitting. Check it out. Anton, I've never heard of this, but thank you very much for the tip. So if that is a technical feasible technology to produce hydrogen, that might be an option for the electrolyzer number 3, which is still not yet decided. So I'll make a note and forward it to my colleagues at the EPC department. I've never heard of this process, so thanks for highlighting this to me.
We all learn something new every day. That's for sure. I suppose a question to all the speakers really is that with this increasing demand now in the marine sector, and we also see it in the aviation sector and also in the heavy transport sector, the issue around availability and scalability. How do you see that playing out over the next few years? So maybe each speaker could address that, say a few words. I think it would be good to hear your views on that.
I could say something and also answer the question of Sigurd Schober that was put only a few minutes ago, that the competition with SAF as well. One way to look at it is that if you have a biorefinery, the higher quality fuel coming out of the refinery could be for SAF, for aviation, the lighter fractions, and then the heavier fractions could go to shipping. In that way, you instead of competing with SAF, you would collaborate to have cheap feedstocks. Sorry, cheap products of both kinds instead of fighting. Jakob, Jürgen seems to be aligned with that idea.
Yeah, I fully agree. We do see at the moment not a competitive situation for maritime fuels versus SAF. It is more the market is just starting, so to say. So any production facility that comes online, whether or not it has, of course, I'm happy if our logotype is on the plate of the facility, but all the companies globally who are developing e-fuels are desperately needed at the moment to get the market going, so to say.
Yeah, maybe I can also put in, we have what we call a first mover advantage. So the companies that are first to the table, they're creating the market. They have an opportunity to get the clients and also to have the contracts. Whereas the incentives with policy is needed for the medium volumes or the longer term to create a baseline for the market. So we have in EU, the FuelEU Maritime Directive that creates a baseline. But so far it's more on free will. That's most of those shipping companies are procuring. But I also think that they are doing it as they don't have an operator license that is forever, and also that client demand is there to have those sustainable solutions.
And Lasse, I don't know if you have any additional comments.
Yeah, well, I do. Like our fear is that there's not too much demand. We need the demand to get the production started, and that's also why we're talking about you need requirements in tenders, you need requirements from the authorities. That's actually stating that, well, if you are going to operate on this route, and if we as a nation are going to buy this service from you, you need to reduce so and so much, and you need to do it this way. Because Norway as a country has an obligation to reduce their CO2 emissions also from shipping. If they are to succeed with that, somebody needs to take point. Somebody needs to start that process. And that doesn't only start with us as the users. It also starts with the production facilities, and then they need incentives to start up. So you have to create a demand also via regulations in such sense, we think anyways, to be able to succeed.
Sure, yeah, regulations is a very important part of it. I think somebody has their hand up there. I don't know who that is.
Jürgen.
It's me, Jürgen. I saw a question here from Alex Lee, which I would like to comment here, and then I read it loud. Finally, sounds like we like to put all carbon back in the air, back to the fossilized phase again. I think this is our human being's destiny. Well, I fully agree with Alex here on that matter. Let me just lower my hand. There we go. And I think the underlying phrase, and I always point this out, is that the strongest driving force that we have to do something about climate change is our behavior as consumers for whatever we do. Buying stuff from China, nothing against China. Please don't get me wrong here, anybody. No? Consuming, going on vacation, and even though I work in the green transition, I do like to go on vacation with my family because that is quite nice and it serves quite a lot of benefits. So whatever we do in our daily life, I think if that has a massive impact. So yes, we will not stop consuming products. We will not stop consuming food is out of the question, but products that you may not need to have. We will not stop this, but we have to make sure that we as an industry make the environmental impact of transporting those goods lesser. And I think this is where the benefit is, that we replace a fossil medium with something less bad. But I'm not saying here buy more stuff, fly more, but we have to reduce its impacts. I always get going when the subject comes up, but it's a consumer responsibility. I think that's the key message here.
Sure. I think there was a few questions around sustainability as well. What is sustainable, and what's your views on that in terms of, I mean, the EU has a particular view, but there's also a global view, and how should that be looked at? Who would like to take that?
I can do it really quick anyways, because we think sustainability is not just reducing emissions and what do we do with the environment. It also has to do with value creation, creating jobs, making sure that people are able to live and work where they want to live and work, especially in a country like Norway, where we have a lot of these smaller communities. Some of our ports have maybe 300-400 people living in the close area to the port. It's not exactly centrally located, but they want to live there, So sustainability is also making sure that we create value to everyone, to our communities, to our countries, to our regions. Of course, in addition to reducing our emissions and our footprint on the world today.
Yes, yeah, that's very important, creating the value chains for the local communities in their environment. Thomas, did you want to add anything else?
I can add that. I think that one key point is also to not add additional hurdles when we are looking for more biofuels into the shipping sector. That also is true for the aviation sector. And we pretty much line up the different categories of the feedstocks to be used and exclude some others. Whereas in other parts of the world, we don't have those categories. And I think that what this study, what it shows, we will show, is to find those low-hanging fruits, how to get more biofuels to the shipping industry, and also replacing the fossil fuel. So by replacing each liter of fossil fuel with the biofuel, you make a value. And we start from this point, and we will be better and more economical, cost efficient, and more sustainable by time.
Well, I think, Thomas, those words is a very good way to conclude this webinar, because we're coming up on the closure now. I would like to thank the four speakers, Thomas, David, Jürgen, and Lasse, for their great input. I'd also like to thank those people that asked questions from around the globe, I would say, and you, of course, the participants. We had a few hundred people that were online for this webinar. This webinar is recorded, and both the recording and the presentations will be shared in a couple of days. So we thank you very much for your participation.
Bye-bye.